Welcome to Renaissance Charge Videos. I'm Rick Friedrich, and this is just another update on the two kits that I have recently upgraded and introduced. So first of all, we'll get out of the way the resonant induction coupler kit, which is now all finished, but will forever be improved upon over time. So I finally completed the book, and of course there's always more editing to do in it. And this is an 89-page book, and it is every single page full of illustrations, or at least every page is filled up so that there's no more room, blank spaces in the book. There is images everywhere and diagrams and what have you. So this is what it looks like. We have this one coil here, but we sell 2 or 3 or as many as you want. And so what I have here today is the update to this kit, which is an option where you can use it as a crystal radio. So you can see this wire hanging here from the ceiling as the antenna. And it's not very much of an antenna. You could make it connect to an actual antenna and outside. And then of course I also have a ground wire. In this case I'm connecting it directly to the ground of the system here. And you have to be, I can't really recommend doing that because of legal reasons, where people could connect to the wrong wire and hurt themselves. So use at your own risk. Anyway, what I've provided is the crystal diode here in the addition, a variable capacitor, which is the nicer one, the more expensive one, and then the earphone, which is also a crystal, and then of course the coil is separate. You can order that on the page. So that's in addition to the kit. Again, this is one of the original types of crystal radios. Instead of a variable capacitor, we have a variable inductor here, which is both sides. Now this is not for sale, just something I picked up. It's an actual crystal here that you have to kind of adjust and hook it all up. And so actually this one worked better than this one, and the crystals kit that I got, it's about a 30-year-old kit here, using the same diode, crystal diode, and using this inductor worked actually better. And the other thing is the rods here. These are AM frequency ferrite rods, and you can enhance, like you can see in this one, it already has it, the smaller one, tightly wrapped around, or the coil is wrapped around the rod tightly. Of course here we have a better Q coil, and this one doesn't have the capability of putting the rod in. So if you put the rod in partially, you can see that it enhances the signal as you're listening. And so depending on your antenna and your ground connection, which is the only point that I make about a crystal radio in the book, is that and we're showing Tesla's the True Wireless article is the main feature. It's actually included in the book, and um, among many other schematics that haven't, some of them have been shown, some of them haven't been. So I have the true wireless included in the book. We go over that quite extensively. But one of the points that Tesla made there was comparing his system with the Hertzian system, in which he shows various illustrations and examples of disproofs of their theory. One of them, which he doesn't come right out and say it directly, but it's implied in what he says, that if you simply connected something like a crystal radio up behind a mountain, and so that if you connect it to the ground and not connect it to the ground, compare it, you'll see a major difference. So it is largely, the signal is largely going through the ground and not through the air. And in Tesla's system of wireless transmission, the antenna is not an antenna, it's actually an elevated capacitance. So transmitting through the air itself, unless it's done at a high voltage, which makes the air a conductor, is not actually efficient at all. You know, the power falls off of the square of the distance, so that's not very efficient at all. But for what we're doing, near field, very near field, it is very good. At least it's not a good transmitter, but it is a good energy generation system. And that's what the whole purpose of the book is. So we're not really focusing on a crystal radio in itself. We're not interested in getting energy from radio stations by any means. But for those who want to verify that one experiment that we mentioned in the book, that's the experiment. So that's all I'll say about that. This is one of the most important works that I've ever produced. This is the accumulation or this is the consummation of many years of research, in which this is more than just, we're talking about 5 or 6 or 7 major themes. Instead of just resonance, I enlarged it. And the title of the book, which I'm not selling this book by itself, comes with the kit. And the title of the book actually says all the themes in itself. And so just the first part of the title is Exploring the Resonance Inductive Coupler Kit, and the rest of it is in the book. Anyway, this is very enlarged instruction manual, which really the instructions are only about 10% of the book. This is, like I said, 89 pages, and the first third of the book is the first section, what we call for the beginner, and that you don't have to go through the remainder of the book. The remainder, the second part of the book is really extensive endnotes, and they're smaller print, smaller font compared to the first part, which wanted to make it really easy for people to be able to do this kit, not get overwhelmed with too many advanced details, and so that they can get through it and then evaluate whether they want to continue in the research and try to make a kit affordable, like I said, with providing a frequency generator or just the bare bones of one to actually do enough of the experiments to really learn some really core important things. Anyway, this to me, even if nobody else benefited from this, this is definitely my number one resource energy book related to all this research. So for me, this is putting a whole bunch of things together in one document, and I find myself sitting for hours just looking at pages. Even though I put this together, it's still, even the front cover is very important. And you can stare at it for a long time because there's so much to learn from this. And you'll be reading, if you get this kit, you'll be reading this book, guaranteed you're going to want to read it 10 times because you're going to learn from it. You can go back to it and say, oh wow. So I don't try and really pump up anything that I do, but this is not that I've done this work. I've organized it from existing materials, and I've put one thing together which is unique, which is, well, there's several unique ideas that I came up with, which was one of them being the idea of presenting the themes and systematizing them, you know, starting from beginning to end and working to a conclusion and making it, so that's one of the benefits of this book that's never been done before. The other is breaking it up into 2 different levels, where you have the beginners levels where they can actually get a taste of those themes, understand them, and not have to go too deep into them. Like I said, I try to make this for an 11-year-old to be able to do this kit, maybe with their mother or father. You know, they could probably do it by themselves if they wanted to, but I do recommend qualified supervision. So that was another aspect or benefit or a contribution that I made to this whole study, which is vastly needed. So many people that try and teach on the subject go over everybody's head. And you know, the vast number of people interested, they want to just get their hands on something and do something. And that's where this kit, that's where we decided this was needed. And then at the same time, I wanted to give something for people that really have been working in this and just not really sure how to organize their thoughts and all this massive information. So just organizing it, systematizing it in a way that lets you say, okay, now I get it. Now I can look at any particular system out there and decide and figure out what about it is unique. What are the different, like I go over the motors now in this way, and it's all in the line of the Loving Paths teaching, which is one of the themes, incorporates at least one of the, well, 2 probably of the themes are included in, are assumed in the Loving Paths teaching. So now we can look at this motor, which I give you a schematic in there of the motor, in which it breaks it down so that you understand where the benefits are, what's important, what's not important in these motor kits. And it's really helpful, because then you don't waste your time. Like I get all the time people trying to spend a lot of time improving upon one area. Like I don't know how many people have said to me, oh Rick, if you just had magnet bearings so you have no drag, then you'd have everything. I was like, no, there's very minimal losses in the bearing, especially when I put the the oil in the bearings like I do. That's not where you need to focus on such things. So anyway, let's get into the motors now. So this is the double stacked motor that was in the previous video without the wires. And I want to go over this for those who have ordered these. I want to mention a couple of things. One is that it's preferable to have two spaces. In the last video I just had one spacer, and that's where it was really tight and cogging and a lot of vibration. And again, the vibration is also due to the fact that there's only 4 magnets instead of 8 on each rotor. Now, that is now obsolete. So we are actually putting 8 magnets now in these rotors, and I'm still waiting on those to come. They're being shipped right now. Anyway, we decided to go back to the 8 magnets because you can also do the shorting of the generator coils, in which the motor speeds up, and that is going to be a future video where we're going to show a new option product that we can do the same effect as shorting out the coils, but under maximum load. So the coils will be loaded down the right way to give the same effect as shorting them out does, which speeds up the motor. So it's a zero lengths effect. And this is important so that the motor will run freely with the generator coils. Like right now there's not that much load on it with the generator coils, but there's still, it loads it down. It slows it down from what it normally does. So we want that to be the opposite. So we want the motor to speed up, and then you can still run whatever mechanical load off of the shaft here, and then end up with a motor with 3 outputs. So you have one input from one battery, which is this battery right here, we're going to look at in a minute. And then we've got one output here into this charging battery. And right now, well, we'll talk about that in a minute. Then we've got the generator coil output, which is going to be this 100-watt LED module. And there's just a bridge rectifier and a capacitor across it right now. This is one that I use all the time. And then we have the mechanical output, which is really considerable amount of power. So once we load this down, like I showed in the last video with generators or what have you, the good part is that the charging even though it draws more power from the battery, it will also charge this battery at the same rate that this discharges. So, or greater if you have a really big battery bank. So that way, well, and I'll say this too, that we'll also have a product in the near future where we have, based upon the principles in this book, series resonance circuits in which we can multiply the output going into the charging battery. So the battery will continue to charge if you do it right at the same rate or even greater, and we can then run additional loads, as many as we want actually, and we can get into a situation where it sends the energy back into the motor and into the input battery, which I showed in the 3rd stage process. So that's in the future, but first we're going to do the generator coil output, in which we then enhance it. So right now, it's functioning like an alternator, these generator coils. And because there's only 4 magnets, in other words, they're out of phase with the motor. When the motor fires on, that's 180 degrees out of phase from the generator coils having the magnets pass them, or the magnets passing the generator coils are, like I said, 180 degrees out of phase. So when we do the 8 coil or 8 magnet rotors, like we've always done with the kits, I just made a run of a short run because I was concerned that if I have the magnets too close, the fields will overlap each other, which they will, and I'm not going to get as great of a charging effect because of that. But I have a really good motor effect, and the generator coils will be really benefited by that, as we're talking about. So that's just the way it is, and I'm not really excited about the fact that it changed it so quickly, but that's just the way it is. It turns out to be better, so we have to make the improvements as they come along. So anyway, what we have here is 4 generator coils on the top, and I have connected them for those who are assembling these. What I do is I turn these generator coils, which actually probably would be better to put the generator coils in on the sides rather than the corners. Put the motor coils on the corners for those who want to assemble these, and that way you can position the hull right off the side. Well, you can probably do it on the bottom one easier, like we're going to do, and then attach it to one of the legs, or like I said, you could put it up here and bend it however you want. I do not have a position for this at this point because it's relatively new design, and you really want to position it where you want it to be positioned, and I don't want to determine that for you. So you'll find that at different voltages that you're running this, you'll want to pull the hull away from the rotor more, which will cut off the angle, the dwell, so that it's basically like this, right, the magnetic field. And so as you position the hull in this field, it will come on or off earlier or later, right? So that's where you get into moving it in the right place. Now the RPM also changes things too, which we're trying to do with the code, make compensation for that. What we'll end up having is many different codes do many different things. So there'll be 12, 24, 36, 48 volt, and we could go higher than that as well. But I doubt too many people will go higher than 48 volts. And this motor is just crazy fast and powerful at 12 volts. So especially double stacked, it's really getting dangerous actually. So I'm really nervous. That's why I wanted to put some kind of load on this to actually slow it down. But when we do the new rotors, again, we're going to have double the on time, which will make it twice as powerful again. And then we'll have the generator coils, if they're shorted or in the same shorted condition, then it will speed up even faster. So that becomes, I mean, I think that we could easily get up to 20,000 RPM on this thing in that situation. Especially, I mean, I'm talking only at 12 volts now. So, you know, I didn't really, this is not a motor to be run, well, I mean, you could run it really fast RPM. I mean, it's really, the rotors are really well machined. This is military grade specs on this, on these aluminum rotors. So it is very well machined, so very well balanced. And you know, like I said, the only limitation is the framing, how you really hold it down, and there's so much torque to it. So anyway, what I was saying is, you put the coils from bottom to top in series all around, and then I just come out with one end here, the other one I'm going down to the bottom layer and continuing it all around. So I have all these in series with each other, and so that way you have you know, the ability to come down in voltage with a capacitor, and you could parallel these up, you could do whatever. You could use some of the generator coils to feed back into the input if you wanted to. Again, if you do it the right way, you can, like, directly connecting it is not the way to do it. You need an isolation factor. Like I said, with a transformer, the right transformer to do that. So again, the generator coils here are in series. Like I said, I recommend that you put them on the sides, and then you put the motor coils on the corners, which is the opposite of what I have here. And then the motor coils, what I have here is, you can see these wires here, and what I have is this one. Yeah, so this one is connected up with this one. So these two are connected, and these two are connected here, the opposite, to the same MOSFET. And then obviously these two are connected to the same the second MOSFET. And I have two layers. So this is the first time I'm showing this board here. So this is the Adreno board, and it's an extended one that we're using on the Duo. It can be used on the Due, I should say. It can be used on the Uno board that we normally make this kit for as well. So it gives enough room to do the four circuits. So I'm doing one MOSFET for two coils, motor coils here. Now the other thing that we've added is these capacitors here, and we put them across the MOSFET and made a big difference, you know, because there's a high spike. When we had the smaller kit with the one MOSFET here, it wasn't that big of a deal, but the inductance is really high here, and there's a really high voltage across the MOSFET, in which is very, it exceeds the internal diode, so that's where you create a lot of heat. Not to mention, it reduces the on and off time, and it does smooth things out. So anyway, that is a big improvement, which we've done on our larger kits as well. So if those of you who have the older, larger kits, you want to make that adjustment, and you can contact me about that. So we have the speed control here, which I'll show running in a minute. We can adjust it with a little pot here. Now what's interesting is we have these 60 watt diodes on here in which we will run what we do is we run two, they're double diodes, and they come out from each MOSFET going into the charging battery. And they are still being bottlenecked. There's so much energy coming out of the system that they are being bottlenecked. So anyway, we'll run this in a minute here, and I think that's it. Oh, the other thing is the northern and southern hemisphere. So this one is actually, I think I reversed the rotors by accident, actually. Just forgetful. Normally, for most of the customers, the northern hemisphere, we're going to have the south poles and the rotors facing up, and then the north poles facing down, so that we're in a bucking configuration. So this one is the opposite. So the wires that you see on here, these red wires, would normally be black, and these all would be in reverse, because what we would have is, I usually use the red wire to go to the input positive, right? So it comes down, so it'd really come down, so those who are assembling these, you'd want to put a red wire on the bottom end of these coils, and the lettering faces downward. This is, again, for the northern hemisphere. And then you've got the red wire going out to the battery positive, the input. And then the black wire, which would be then again on the top, which is the opposite of what we have, would go down to the center terminal on the MOSFET. And so that way you can have the idea of positive, negative in your mind. But when you're doing that, just make sure whatever rotors you have in here, if you've already assembled them and you don't want to pull them apart again, then just take a little battery like we have here and just pulse across the coil when you kind of move the coil slightly, and if it pushes away, then you're good to go. That's the polarity that you want. But if it pulls it in, then just reverse the wires so that it pushes out. So that's that, and what we'll do, I'm just going to stop the camera here and then I'm going to run it. My problem was I had the wrong diodes on here. I just realized that. So I wanted to run them with the right diodes here. So we're going to start this up now. And this is the charging battery that's the voltmeter is hooked up to. So I'm going to go on the bottom here with the hull facing up. Like I said, the hull faces towards the south pole of the magnet, so you have to orient it where the face is facing the south pole. So we have an amp meter here, and it's about 10 amps right now. Start up. Depending on what power level you have it set to. So this is the charging battery, you can see it's charging. Now we've got this really bright light going on here. Now we can change the speed control on here. You can bring it down. Right? So now we're only at 3.5 amps. So let me go on the top here. So we have this really light running now. You can hear the oscillations. Speed it up again. So again, this is under load. That crackling sound is the lube getting into the bearings. So this is 8 amps now. Very, 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 very fast. So you can see as I move the hull side to side or front to back, it affects the generator coils. So I'll show the light now. So you can see the influence of the motor on the LED. So we'll turn off some lights here and we'll get going. So we do have, in this situation, the ability to do the true 100 watts on this LED, which is getting hot now. It will get hot depending how hard you run it. So it's not, that LED is not rated for the voltage that I'm running it at, so it's not the best situation here. So you can see it's really bright. It's completely blinding here. So then I want to run this in a way that shows you when I disconnect. What happens when I disconnect the just keep it running here. So I'm going to cut off the let's go underneath here. So I'm going to cut off the load. Ouch. That's very hot. Now I can't see. See now, sorry, I'm going to burn up that bulb if I'm not careful, because usually you got to have a better heat sink on there. So I'll leave this here. Now watch what happens. We're only at 5 amps now. So you can see the difference. I didn't have a switch on there, so you can see now it's speeding up. Now it's at 4.8 amps now. You can see the speed is very fast. It's still going. And I can't even touch that. Okay, so now it's almost deafening. It's so loud in the it's going so fast that it's pretty loud. So anyway, what I want to get at is, and I want to mention, is just how that was speeding up from a loaded position, which represents like a resistive load type of, well, Anyway, I won't get into that part until the next video. It represents a shorted load, like an alternator. And so what we want to do is, with the new rotors now, we'll have it so that when you short it out, just in the same way that it went from a lower RPM to the higher RPM unloaded, it will go to the same extent, it will go even faster when it's loaded with the dead short, or the equivalent with the new upcoming kit. It's going to be an option down the road, maybe in a month or so. Anyway, you can see how fast it was. It was really fast. So now if you were to do the same thing and go higher yet under a shorted coil situation with the generator coils, then it would be really, really fast. And this is only at 12 volts now. If I started putting 24 volts on here, I would definitely want to be kind of separated from this thing because it's just so fast. And I don't have right now I'm not going to go into too much showing of this particular model because this is obsolete already. This is just for those people who have ordered these these kits with the first orders of this kind of new model. And now we have yet another new model, like I said, with the 8 magnets per rotor. So in that video, once we get the new rotors in, I'll do another video showing the actual RPM at 12, and maybe we'll go up to all the different voltages in a real controlled manner. So it's a work in progress. Like I said, we'll have various options for these boards in which we're running just the basic system where we are controlling the motor, and there's a whole bunch of different code capabilities there where we can control it by RPM and lock in a certain RPM, so whatever the load is, it always maintains that RPM. And then we can adjust the on time, the dwell of the signal from the hall. We can adjust it so that when it gets to a certain RPM, it changes it, which is important. The timing changes at different RPM, the ideal setting. So that is another benefit that we've learned and are incorporating into new code. Then we have the battery rotating code that it shuts off the motor momentarily, switches relays to rotate batteries around, and we can set that for any particular time, or even we can get into doing a voltage sensing so that it changes the batteries when a certain voltage has arrived, and that we can do all on the same board here. I mean, this is kind of running out of space on this board for doing that, but it's just 2 more components on the board that we just have to add. So it's all set up for that, and then we can get into also monitoring and having the system adjust to the generator coil output too, if we wanted to. So there's a lot of options in this coming up here, and even for the older models, some people are planning, well, what can we do with what we already have? And so we can apply all these things to the older models it's kind of funny when you think about this was once just a reed switch and transistors, and now it's got a lot more potential to it. So that's the new double stacked obsolete motor. At least the rotors are. But as you can see, it's very powerful. That was, when I ended it there, it was only at 4 amps, 12 volts. And that's very powerful. So you can see under load, I was drawing more. But once we get into the zero lengths effect, we'll have a free load. That light will actually only enhance the motor. So that light represents the same amount of power pretty much coming out of this battery, and of course we're still charging this battery at the same time, so we can have 3 outputs. So ideally, like, let me say this again, I said it in the last video, this is what I get into in this book, where you have ideally you would have this. You have, and I know some of you are doing this already, you have 24 volts, for example, on the front end through the second stage process, 2 banks of 12 volts, all equal batteries, and you're running the motor through the positive terminal, and you're still charging a 12 volt battery, right? And then you are running those back and forth to each other. They maintain each other. This is when it's all done just right. Then you have your output to your charging battery, and in series with that, you have as many outputs as you want. Each one of them being the same amount of energy going to the battery. And you can just multiply that out again and again with like an upcoming product that we'll do. And so that's one way. And then on top of that, you have generator coils, which also you could multiply the output out. But on the next addition option for this kit will be where we, as I said, have a equivalent of shorting out the coils. So then the motor speeds up even more, and then you have a free load when you fully load it down, not when you not fully load it down. So you have then as many outputs as you want. And in this case, you don't have to have the 2 battery banks in the front either, but that's an easy way of doing that at the beginning, so it maintains itself. So if we just scrap this battery bank number 2 here, and we just go the way we have it here, we can also get into with the additional process, the 3rd stage process, as I said, charge up this battery at the same time. And then the actual voltage, operating voltage and power will be higher on the motor as well. And we've made it so it's protected now on the circuits so that it doesn't blow out your MOSFETs and transistors as we were doing a couple of years ago when we were trying to do that effect and push more energy back into the input. There was a danger of doing that, and it's too high of a voltage spike across the semiconductor. It can't really handle that, especially on the gate, and that's what we have finally solved, and it works out really well. And then actually we can use that destructive power again and reintroduce it into the system. So it's getting to what we talked about in this book is Tesla shuttle circuitry, where we're shuttling around the energy that's normally considered a destructive force. And normally we're doing that into a battery, but here we're actually reintroducing it back into the system. So for more power into the motor, which is, more or less being done in regular circuitry, but we're doing it in a different way. So that is what I wanted to share at this time. And what we'll do, like I said, is we'll do another video showing the new rotors coming, and we'll also like first I'll do one layer showing that, and we'll probably hook up the generator to it as well, and then we'll show the effect maybe in a video after that. We'll show I'll show it shorted, and then I'll say, hey, like I said already today, if you add the same shorted condition, which is what we can do already, we can run a load for free. So instead of just shorting the coils out and having this thing spin faster, we still do that with powering a load. So that will be maybe 2 videos from now. So thank you for watching. Hope you enjoyed it.